Hi everyone, it's Mrs. Bebo. In this video, we're going to continue our conversation about equations of proportional relationships. In this part 2 of that video series, we're going to specifically look at actually writing an equation for a proportional relationship from scratch. And then later on, there'll be examples where we actually have to apply that equation to find some other information. So taking a look at our first example, which is example 4 if we're continuing from our previous video, it says, what is the equation for a proportional relationship where the constant of proportionality is 3 and 25/100ths? So first thing, they tell us it's a proportional relationship. So that helps us know that, hey, this is going to be in the form y equals kx. So if I know it's going to be in the form y equals kx, we just have to figure out what k is, or maybe we have to calculate what k is. But in this case, we don't have to do any calculations. They tell us in the problem that k is 3 and 25/100ths. So all we have to do is plug it in for k. So this is going to be y equals 3 and 25/100ths x. And that's it. Done. So if you can remember that the equation, the form of an equation for a proportional relationship is y equals kx, these problems are going to hopefully not be too bad. All right, so let's take a look at one that we have to do a little bit more work for. So this is example 5, our second one in this video. It says JC bought 8 gallons of gas for $31.12. We're going to write an equation relating the total cost y to the number of gallons of gas x if it is a proportional relationship. Now, again, they're telling us that it's going to be cost and gallons, so y to x. And so if we're going to write this equation, because they don't tell us straight out what k is, we are going to have to do that calculation. And again, if we remember, k is equal to y to x, right? That ratio of y to x. So in our problem, they tell me that there's 8 gallons. Well, that's our x value. $31.12, that's our y value. So we're going to have our ratio 31 and 12/100ths to 8. And then we just need to simplify this. So whether you get to use calculator, maybe you have to do some long division, we're going to be doing 31 and 12/100ths divided by 8. And so calculating that out, we end up with 3 and 89/100. So again, as a unit rate, just a little side note, especially if we're still trying to, if we're still encountering questions where we have to interpret what the constant of proportionality means, this means that it's $3.89 per gallon. Now, this question does not ask us to do that, but I still think it's good practice to just remind ourselves that to interpret or explain what it means in the context of the situation, basically you're adding some labels to it. All right. We're not done here though. So I've had students in the past make this mistake where they're like, look, I got the equation. Because this is technically an equation. K equals, right? You got your operators, you got a variable in there, and you got an equal sign. But this is not in the form that we're looking for our proportional relationship. So we need to go to a part 2 where we're actually writing it in the form y equals kx. And so all we have to do is actually plug in what we found for k into this equation. So my final answer is going to be y equals 3 and 89/100ths x. And then that's it. So we calculated what k was based on what they told us y and x were. We wrote that ratio. We simplified it. We did interpret it just so that we could get that practice. And then we put it in the form y equals kx. Done. Next example. Very similar situation, so just one more to really make sure we're good with this. A mechanic charges $270 for 5 hours of work on a car. We're going to write an equation that compares the total cost to the number of hours he works on a car. So when we write out this one, now this one's a little bit different because they actually don't tell us what x and y are, but they are telling us that we're comparing the total cost to the number of hours. That is telling you how you're writing that ratio. We're doing y, again, to x. So our k value of y to x, the cost is going to be our y value, and then our time, or hours, is going to be x. And so we're going to do 270 divided by 5. And find out we get 54. And just as a little reminder again, if we were to interpret this, this is just telling us that the cost is $54 per hour. All right, so now that we figured out what k is, we have a part 2. So we're not done after we calculate k. So don't make that mistake and stop there. We still have to write it in the form y equals kx, where now we can actually put in a value for k, the one that we just calculated, which is 54. So y equals 54x, and that's it for that question. All right, so let's try one more to really make sure that we're getting this one down. Now, this one, if you are quickly glancing at it, it does now have our variables y and x in there, so we don't have to piece that information together. This one says that Trina earns $28.50 tutoring for 3 hours. We're going to write an equation that can be used to model the amount of money earned in x hours. So money is going to be y. The number of hours is x. Remember your k value, because that's the first thing we have to calculate. To write this equation, we need to know what the constant of proportionality is. K is going to be equal to the ratio of y to x. So we're going to end up doing $28.50 divided by 3. And we find out that that is 9.5. Or again, if we did have to interpret what this meant, this just means you're making $9.50 per hour for your tutoring job. Last but not least, after we figure out what k is, we're actually going to put it in the form y equals kx. So now that we know what k is, y equals 9.5x. So that is the equation we can use to model this situation. All right, so for this next example and the next two after this one, they're going to step it up a little bit in just the level of difficulty, because we're going to have a little bit more going on. So for this first one, it says the perimeter of a square is proportional to the length of one side. A square with 10-inch sides has a perimeter of 40 inches. Write an equation relating the perimeter of the square to its side length, then find the perimeter of a square with a 6-inch side. So when my students first see this question, they get kind of confused because now we're throwing in some geometry. One of the things that we have to remember is that a square has all equal side lengths, right? So they're telling us in this question that you have 10-inch sides, there's a perimeter of 40 inches. So we're going to know based on this, right, if we had to sketch out a picture of a square here, again, all the sides are the same. They're telling us, again, 10-inch sides, it's going to be 40 inches all the way around, which makes sense, right? Because this is 10, this is 10, this is 10. So perimeter is going to be equal to 40. So that's all that sentence tells us. So we're going to write an equation relating the perimeter of the square to its side length. Then we're going to find the perimeter of a square with a 6-inch side. So the 6-inch side is us going to be applying that equation to a different situation. So first we have to come up with the equation. So don't jump to the part 2 until you have part 1 completed, right? So to help us figure that out, they're telling us that the perimeter is proportional to the length of one side. So that again is the order in which we're going to divide. So the perimeter to the length of one side. So our k value is going to be equal to the perimeter divided by the length of one side, 10. So 40 to 10. Simplifying this, we find out that our constant of proportionality is 4. And so when I write my equation, which is what's going to help me answer part 2, we're going to have y equals 4x. Okay, so that's part 1. All we did there again was take our perimeter and we divided it by the side length, because they told us that the perimeter is proportional to the length of one side. So that is the order in which we are writing our ratio for k. So now that we have that figured out, we can go through and answer the second part of our problem. Find the perimeter of a square with a 6-inch side. Well, our side length is represented by x, right? Because again, this is your y to x over here. So if you ever forget what's talking about what, especially in a question where they don't specifically say what y and x are representing, that order in which you divided tells you what, again, your y value is and what your x values are referring to. So the side length is our x value. So when I look at this equation, y equals 4x, the one that we specifically came up for this situation here, we're just going to replace x with the side length, in this case 6. And 4 times 6 is 24. So the perimeter for a square that has a 6-inch side, based on the relationship that's presented here, is going to be 24 inches. So those are our 2 answers for this question. All right, example 9. Cindy's going to pay $34.60 for 4 tickets to a movie. We're going to write an equation relating the cost to the number of tickets. Then we're going to use the equation to find the cost of 7 tickets. So again, these are the examples that are going to have a part 1, but then also a part 2, right, where we have to actually use the equation. So for part A, to write the equation, again, we need the value of k. So an equation for a proportional relationship, we are going to be in the form y equals kx. So we got to figure out what k is. Now, again, in this problem, they don't specifically tell us what y and x are. But when I look at what they want me to relate to one another, the order in which they're writing it, cost to number of tickets, tells you the order in which you're writing that ratio. Because again, when you're writing this proportional relationship, there's a ratio between y to x in that order. So my k value, again, y over x, is going to be your cost. So in this case, $34.60 to the number of tickets, which in this case is 4. So $34.60 divided by 4 is going to give us $8.65. So it's $8.65 per ticket. So if we had to interpret it, that's what we would say. But in this, they just want us to write the equation. So 8.65 or 8 6500ths. So that's part A. We wrote the equation after we figured out what k was. Hardest part with that, again, is just making sure that you're getting the correct value for it by doing your ratio in the correct order. It's always y to x. Part B, we're going to use the equation. I know this says solve the equation, which we are eventually, but we're going to use that equation to find the cost of 7 tickets. So again, we just have to remember what tickets, not what tickets, but what variable is representing the tickets. And if we look back at the beginning part of this, number of tickets is x. So that is what we're going to be putting into our equation that we came up with. So y equals 8 6500ths x. If I replace x with the number of tickets, in this case, we're looking for the cost of 7 of them. Again, we're just going to multiply that out, and we're going to find it's a total of $60.55. All right, last example. So we're looking at a running problem. Hugo can run 4 miles in 25 minutes. We want to know how many more miles can Hugo run in 90 minutes than in 25 minutes. We're going to assume that the relationship is proportional and he runs at a constant rate. He is Mr. Consistent when he runs. So first thing we need to do in this problem is actually figure out what is his unit rate, right? What is this constant rate that he's running at? So essentially your k value, right? The constant of proportionality. So looking at the initial information that's given to us, we're going to go through and figure out our equation. Now with this problem, our equation, it really doesn't matter the order in which you do your y and x, because again, this problem doesn't tell us if miles is y or if miles is x. And you can solve this problem either way as long as you're, again, keeping in mind how you are relating those two values, right? So if you're picking y to be miles and x to be number of minutes, make sure you keep that consistent, right? So with this question, I'm going to go ahead and just do, I think, minutes divided by miles, just so I don't have to deal with too many fractions or decimals in this case. So I'm going to let minutes, so if I'm going to do minutes to miles, that means the minutes is my y value and miles are going to be my x value, and that's going to be important to keep in mind. So again, this is going to be my ratio of y to x to help us figure out what k is. So if I do 25 divided by 4, I find out that that's 6 and 2500ths. And so my equation for Hugo's running, he is at y equals kx, so y equals 6 and 2500ths x, right? So this equation is going to help me figure out how much he can run in 90. Now, we already know in 25 minutes he can do 4 miles, but we want to know how much he's going to be doing in 90 minutes. And so we're going to, again, plug in 90 into our equation. But we have to keep in mind what value is talking about what. So if this is 90 minutes, remember we did minutes as our y value. I did for this example anyway. Again, you could have reversed it. You would have had a different k value, and then you would be plugging in minutes for x. But with the way that I set up this problem, I decided to do it so that I wouldn't have to deal with too many small fractions or decimals. And we ended up with 6 and 2500ths as our k value. So we're relating the minutes to miles. So this is basically you're doing 6 1/4 minutes per mile. So with that being said, 90 minutes is our y value that we're going to plug in. So 90 equals 6 and 2500ths x. And then this is just a really good reminder. How do we solve a one-step equation like this, right? So to get rid of that 6 and 2500ths that is being multiplied by x, we're going to divide both sides by 6 and 2500ths. And so 90 divided by 6 and 2500ths is going to give us a grand total of 14 and 4/10 for x. So that again is your number of miles. So again, if I had done this backwards, you still could have solved this, but basically your k value, you just would have multiplied by 90 and you still would have ended up with the same answer, 14 and 4/10. So with that being said, well, we did 4 miles in 25 minutes, but then we did 14.4, 14 and 4/10 in 90 minutes. Well, and that means, right, if we subtract these, that you did 10.4 miles more than what you could do in 25 minutes. So that would be our final answer for this question. Hopefully that helps with the equations of proportional relationships concept that you are covering in your class. And that's it for this time. Thanks for watching.